What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, find the values of x and y for which the square root of 2 to the square root of x minus the square root of 2 to the square root of y is equal to 60. Well, our first step will be for us to rewrite the base. So, the square root of 2 is same as 2 to the half. And this is raised to the square root of x. So I'm going to be raising this to the square root of x. Minus the square root of 2 is same as 2 to the half. And this is raised to the square root of y. So raise this to the square root of y equal to 60. Now, our next step will be for us to apply the law of indices, which says when I have a base a raised to the m, and this is raised to the n, the law of indices says the powers multiply. That means this becomes a to the m times n gives mn. So that means we're going to be multiplying these powers. The power here is half times the power outside is the square root of x. So this will give 1 times the square root of x is the square root of x all over 2. And the same thing happens here. The power here multiply the power here to give the square root of y over 2, just like this one. So our expression now becomes 2 to the square root of x over 2 minus the same thing here, 2 to the square root of y over 2. And this is equal to 60. Now, our next step will be for us to introduce substitution. We can say let the square root of x over 2, so the square root of x over 2 be equal to m, and let the square root of y over 2, so square root of y over 2 be equal to n. And in that case, we're going to be rewriting this. So this becomes 2 to the m minus 2 to the n equal to 60. And now, in order to have a positive value of 60, that means the value here must be bigger than this value, which means this m, the exponent m, must be bigger than the exponent n. In other words, m is equal to n plus some positive integer k. So let me write that, where k belongs to positive integer. So we're going to be substituting this here. So this expression now becomes 2 to the m, and m is n plus k, so n plus k minus, this is 2 to the n, equal to 60. Now let's move forward to the next slide. All right, so our next step will be for us to apply the law of indices to what we have here. The law of indices, which says, for example, when I have a to the p plus q, this is same as a to the p times a to the q. So now let's apply this to what we have here. So this expression now becomes 2 to the n times 2 to the k minus 2 to the n equal to 60. Now notice that 2 to the n is common. That means we're going to be factoring out 2 to the n. So 2 to the n factored out. Now 2 to the n times 2 to the k, divide by 2 to the n, I'll be having 2 to the k. So 2 to the k minus 2 to the n divided by 2 to the n. I'll be having 1 equal to 60. Very good. Now, there is something we need to put into consideration, that when I have 2 raised to a power, no matter the power 2 is raised, we're going to be having an even number. So that means what we have here, or this factor, is always even. Now, what about what we have inside of the bracket? Well, remember, 2 to the k is even, because when you raise 2 to any number, you're going to be having an even number. But when you subtract 1 from an even number, you get odd. That means this value here is odd. So we have 2 factors for which one is even and the other is odd. So our next step will be for us to write down all factors of 60. So for factors of 60, we have 1 times 60. This gives 60. We have 2 times 30. This gives 60. We have 3 times 20. This gives 60. Then we have 4 times 15. This gives 60. Then we have 5 times 12. Gives 60. Now remember, one of the factors must be even and the other odd. Now this is odd and this is even, so this is a tick. This is even and this is even, so we're not going to be using this because one of the factors must be odd. Now this is odd, this is even, this is even, this is odd, this is odd, and this is even. Very good. So now we're going to be using this one after the other to see which one fits to give us our solutions. Now let's start with the first one. So I'm going to be taking the even factor, which is 2 to the n, and pair it with the even factor here, 60. And I'll take the odd factor, which is 2 to the k minus 1, and I'll pair it with the odd factor here, 1. Now there is something I failed to mention, that n is a natural number. Well, in order to have a natural number of n, the base on the left-hand side and the one on the right-hand side must be the same. But if I have to make the base on the right to be 2, there is no number to which I can raise 2 to give 60. And because of that, we're going to be rejecting this. Now let's go to the second one. I'll take the even number, which is 2 to the n, and pair it to the even number here, 20. And I'll take the odd. The odd is 2 to the k, 2 to the k minus 1, and I'll pair it with the odd number here, 3. And the same goes for this. There is no number to which I can raise 2 to give 20. And because of that, I'm going to be rejecting this. So this is rejected. This is also rejected. Now what about this, which is the third one? I'll take the even number, which is 2 to the n, and I'll pair it to the even number here, which is 4. Take the odd, 2 to the k minus 1, and I'll pair it to the odd number here, 15. Now notice that 4 will work. So what I'm going to do, I'm going to be raising 2 to the power of 2, which gives 4. Now notice that the base on the left and the base on the right are the same. So we can just equate the powers. So easily you see that n is equal to 2. Now what about this second one? Now let's move -1 to the right hand side. We have 2 to the k to be equal to 15. As -1 crosses, it becomes +1. So when I add this 15 plus 1, I'm going to be having 16, which is same as 2 to the 4. Now you notice the base on the left and the base on the right are the same. So we can equate powers, making k to be equal to 4. Very good. Now, let's try for this. So that's going to be our fourth one. So we have the even number, which is 2 to the n. We're going to be equating this to the even number here, 12. Take the odd, which is 2 to the k minus 1, and equate to the odd number here, 5. Now you see that there is no number to which I can raise 2 to give 12. So I'm going to be rejecting this as well. So we've only got n to be 2 and k to be 4. Let's move on to the next slide. Now recall that we have m to be equal to n plus k, right? Very good. So now m will be equal to n. We've got n to be 2 plus we've got k to be 4, making the value of m to be 2 plus 4, that's 6. Very good. Now, in order for us to get the value of x and y, we're going to be bringing back our substitution, which says the square root of x all over 2 is equal to m, and the square root of y over 2 is equal to n. Now, let's substitute one after the other. So the square root of x over 2 is equal to m, and the value of m is 6. Now let's cross multiply. Now on cross multiplying, we're going to be having the square root of x to be equal to 2 times 6 is 12. Now to get x, we take the square of both sides. So I'll square the left hand side. I'll also square the right hand side. Now the square cancels off the square root, leaving behind x to be equal to 12 squared is 144. Now let's focus our attention on this. Here we have the square root of y over 2 to be equal to n. And the value of n we got is 2. And let's cross multiply. On cross multiplying, we have the square root of y to be equal to 2 times 2 is 4. And in order for us to get the value of y, we'll take the square of both sides. And the square here cancels off the square root, leaving behind y to be equal to 4 squared is 16. Now, the values of x and y, which we have calculated, are x is 144 and y is 16. And there you have it. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.